Brown eyes. Brown eyes offer the strongest natural defense against bright light and UV radiation. High melanin content acts as a biological shield, absorbing harmful ultraviolet rays and reducing glare. For early humans in sun-drenched environments like the African savanna, this trait preserved visual clarity and prevented eye damage from constant, intense sunlight. The melanin filters and absorbs incoming light rather than scattering it, making brown eyes stable and less reactive under varying conditions. Over 70% of the global population has brown eyes. In candlelight or golden hour, they can reveal warm amber undertones. The trade-off: brown eyes excel in bright conditions but may have slightly reduced low-light performance, a rare blend of protection and durability. Blue eyes. Blue eyes evolved as an advantage in low-light environments, particularly northern regions where sunlight was scarce and winters long. With very little melanin, these eyes allow more light to enter, enhancing visual sensitivity in dark conditions and adaptation for colder, darker climates. The blue appearance comes from Rayleigh scattering, the same effect that makes the sky blue. Shorter blue wavelengths bounce outward while longer wavelengths pass through. Blue eyes shift noticeably with lighting, ranging from icy bright to soft gray. All blue eyes trace back to a single mutation 6,000 to 10,000 years ago. Though they offer minimal UV protection, their light sensitivity gave populations a selective advantage in darker climates. The vulnerability: more light enters, but so does potential for UV damage and glare sensitivity. An evolutionary mix of sensitivity and advantage. Green eyes. Green eyes strike a rare balance between sensitivity and protection. With moderate melanin and a yellow pigment called lipochrome, they allow moderate light absorption while responding to environmental changes. This adaptability helped early humans thrive in temperate climates, with variable lighting forests or mountain regions where neither maximum sun protection nor extreme light sensitivity was ideal. Only 2% of the global population has green eyes. Their hue results from precise pigment blend: too much melanin shifts them brown, too little blue. They appear mossy in shadow and golden green in sunlight. Their rarity has made green eyes symbols of mystery and intuition across cultures. They require UV protection, but offer better bright light tolerance than blue eyes, a combination of rarity and adaptability. Hazel eyes. Hazel eyes offer unique versatility, sitting between light and dark on the melanin spectrum. They're equipped for varying environments: sun, shade, or changing seasons, making them adaptive in mixed light regions. Their balance allows moderate UV protection and reasonable light sensitivity, a functional middle ground for transitional climates. Unlike fixed colors, hazel eyes are dynamic. They contain intermediate melanin and traces of lipochrome, shifting from green to gold to brown depending on lighting and surroundings. This ability is physical, driven by how the iris scatters light as conditions change. Found in people of European or Middle Eastern ancestry, hazel eyes represent a genetic blend, bridging dark and light with a chameleon-like appearance, a perfect evolutionary compromise. Amber eyes. Amber eyes may have evolved less for function and more as a visual signal. Extremely rare and marked by high lipochrome with little melanin, they produce a golden, copper, or honey-colored iris that stays consistent under all lighting. Unlike hazel, which shifts, amber eyes remain richly golden. This coloration is common in predatory animals like wolves and owls, which may explain why amber eyes feel instinctively intense or commanding. Humans may subconsciously associate this color with alertness or confidence traits, offering subtle social advantages. Present in less than 5% of people, amber eyes are often mistaken for light brown, but their uniformity gives them distinct identity. Found most in Southern European, Asian, or South American descent, they require UV protection but offer better defense than blue or gray eyes. A rare balance of visual impact and function. Gray eyes. Gray eyes are exceptionally rare, containing even less melanin than blue eyes. Light scatters more diffusely across the iris, creating a steel-like appearance. This trait likely helped early humans in low-light regions like Northern Europe by maximizing visual sensitivity in dim or overcast conditions where every photon mattered for survival. Their neutral tone reflects light across multiple wavelengths simultaneously. Depending on lighting, gray eyes appear silver, slate, or subtly green. This makes them visually stable, yet emotionally unreadable. Culturally associated with wisdom and emotional control, perhaps because their minimal color variation makes expressions harder to interpret. Found in less than 3% of the population, gray eyes share vulnerabilities with blue eyes, high light sensitivity, and UV risk, but their rarity makes them one of the most quietly striking colors, a combination of extreme sensitivity and mysterious beauty. Black eyes. Black eyes are not truly black, but extreme dark brown from dense melanin concentration. This saturation makes them highly effective at absorbing light, offering maximum protection from sunlight and glare, an advantage in equatorial regions where UV exposure is constant. For early humans near the equator in Africa, South Asia, and Southeast Asia, this provided ultimate natural defense against sun damage. Black eyes are best at filtering harsh light and stay visually stable in all conditions. Unlike lighter eyes that scatter light, black eyes absorb nearly everything, appearing deep and difficult to read. This minimizes eye strain and may lower risk of UV-related conditions. Common in populations from Africa, South Asia, and Southeast Asia, black eyes have been linked to themes of mystery and strength, the strongest evolutionary shield nature could provide. Heterochromia. Heterochromia occurs when someone has two distinctly colored eyes or color variations within one iris. Its evolutionary advantage lies in genetic variation and developmental flexibility. While not adaptive like melanin-based colors, heterochromia may reflect mechanisms, allowing the body to respond flexibly to environmental or genetic changes. In rare cases, it's linked to mosaicism or localized mutations, affecting more than just eye color. Heterochromia occurs when melanin distribution is disrupted during development, often from minor genetic mutations. These typically don't impair vision but alter pigmentation patterns. Affecting less than 1% of the population, heterochromia isn't always inherited. It can result from injury, inflammation, or developmental variation. Historically seen as signs of duality or mystery, perhaps because they break expected facial symmetry. This asymmetry creates memorable, distinctive appearance, offering social advantages through uniqueness. Functionally, each eye retains advantages of its specific color, a rare reminder of human genetic unpredictability. The universal truth, regardless of your eye color, the hidden advantage lies in understanding how to protect and optimize them. Lighter eyes benefit from superior low-light performance, but require strict UV protection. Darker eyes handle bright conditions naturally, but still need sun protection. Every shade carries evolutionary wisdom, a reminder that your ancestors survived because your eyes helped them adapt. The real power isn't in having one color over another. It's recognizing that your eye color is a biological inheritance, a functional tool shaped by environment and time, carrying both strengths and vulnerabilities you can consciously manage. What advantages have you noticed with your eye color? Share your experience in the comments, and subscribe for more fascinating insights into human biology.